Now children, having understood what is the difference between linear inequation and equation, we have also seen what are the laws which we need to know for linear inequation. So after seeing these two, let's see two examples. Now what I have given the title as simple examples on inequation, its solutions and line graph. Now we are not taking any sum as such, but I'm sure, 100% sure that if you understand these two sums, right, these two sums are going to help you a lot while doing the sums, right? More or less we are covering many types of sums and their solutions. So within these two sums, I'm going to give you more permutation combination. We are going to use different markers for different kind of varieties which we can create in this particular question itself, right? And we try to produce their solution. Mind you, all these solutions are going to help you for your actual sums when we go and do the sums based on linear inequations. So let's start. Let's read what it says. Simple examples on inequation, solutions and line graph. First question. We are being given the inequation as 3 is less than x less than 7 where x belongs to I, means set of integers. 3 is less than x less than 7 where x belongs to I, which is set of integers. Now before we start children, what I would like to say, keep this in mind, that whenever they say draw line graph, right, we have to first write down the solution set. Without solution set is what we cannot directly go and draw line graph. For every linear inequation, solution set is must. For every linear inequation, solution set is must. It's only after solution set we happen to go and draw the line graph. This was point number 1. Point number 2. For x belonging to integer, whole numbers, natural numbers, the solution set will be in listing form. I reiterate, for x belonging to set of integers, whole numbers, natural numbers, the solution set is going to be in the form of listing form, right? But when it comes to x belongs to real number, the solution set will be in set builder form. The solution set will be in set builder form. Kindly keep this in mind. I am going to put it across everything, but this should be kept in mind. Integers, whole numbers, natural numbers, solution set should be in listing form, and for real numbers it should be in set builder form. Let's start with our question. 3 less than x less than 7 where x belongs to integer. Now what will be the solution set for the same? The solution set SS is going to be, since x is less than 3, less than 7. So if x is less than 3, what value x can take? X is more than 3. X is more than 3. So for what value x will take? X will take the value as 4, 5, 6. Will I take the 7 one? No, I cannot take. Why? Because x is less than 7. It is greater than 3. That's the reason we went for 4, 5, 6. But it is less than 7. My solution set comes to an end. Sir, this is the way which we used to represent in sets also. Absolutely. We have to present in a set language. So solution set, the elements inside this particular solution set is going to be x is greater than 3, x is less than 7, 4, 5, 6. Now the question arises, you all have learnt all these things. The question arises, what if the given question has x is less than, or x is greater than or equal to 3 and less than or equal to 7. So I read the question as 3 less than or equal to x less than or equal to 7. In that case, my solution set would be, mind you, we have changed the question, and that's the reason my solution set would be 3, 4, 5, 6, 7. I hope my children are getting this. Right? What they have said, first 3 less than x, first one, where this was not there. 3 less than x less than 7, the solution set will be 4, 5, 6. When now we say 3 is less than or equal to x less than or equal to 7, we have to include 3 and 7. Why? Because less than or equal to sign is there on either side. That's the reason we have included 3, we have included 7. Right? What if they say 3 less than or equal to x less than 7? If they erase this one, then even 7 will not be a part of our solution. and there won't be any comma also. So one thing should be kept in mind, after every element a comma should be there, right? If I modify this question, 3 less than or equal to x less than 7, 3, 4, 5, 6, and our solution set comes to an end. But as of now, I'm keeping this particular less than or equal to 7, and my 7 will be here, and my 7 will be here. So having understood what is the solution set, we'll now try to understand the line graph. How the line graph is going to look like. How the line graph is going to look like, and what are the things which we have to pay attention. What are the things which we have to pay attention to? Please pay attention to whatever I say. Please pay attention to whatever I say. So 4, 5, 6. So this is my 4. Always write down the solution first. That means the elements of the solution set should be written down first rather than drawing a big number line. There are many students who have this habit. Whenever a number line is being asked to draw, they start always from 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, and then they try to plot down those answers, solution set. Please don't do that. Always plot your solution set first. Always make a habit so that you do not go for unnecessary elements in a number line. So 4, 5, 6. Since x belongs to set of integer, we have to put a dark circle onto the solution. I repeat, 4, 5, 6, dark circle. Right? Next, what is the law for presenting a solution set onto the number line? Law says we have to have an extra element. We have to have an extra element on either side. We have to have an extra element on either side. So here it's going to be 7, here it's going to be 3. Here it's going to be 3. Please keep this in mind. I have said, and I always tell my students that instead of going for one extra element, go for 2 extra elements. Instead of going for one extra element, I always prefer 2 extra elements. I shall give you the reason in one of the sum. Why I prefer an extra element, right? Or else even here also, if there is an opportunity, I shall tell you that also, why we provide, instead of one element, we go for 2 extra elements. We are done with the first part. What if the same thing happens over here? Then our answer shall be, first always jot down the solution set. So 3, 4, 5, 6. Actually we need to represent only one extra, but I'll say 8, 9 to be on a safer side. If I extend this slightly, here it is 2 and 1. But see to it that our main solution should be given a bigger dot. Compared to the others. Are you getting me, children, now? Sure? Let's move on further. Now visualize if the same sum were to be given to us, and they say here, I'm writing the same sum, mind you. 3, initially what we went for, 3 less than x less than 7, but now x belongs to set of real numbers. There are various ways to present line graph of real numbers. 3 less than x less than 7, x belongs to set of real numbers. So as I said, our solution set will always be written in set builder form. We are not supposed to write down in listing form. So solution set comprises of all x. Such that x belongs to real number, and we write down the inequation. Right, children? Okay. Now comes presentation of the line graph. How we present it. X is greater than 3, less than 7. Mind you, greater than 3, less than 7. Now when I say greater than 3, 3.01 comes in it. 3.001 comes in this solution set, but 3 doesn't come in the solution set. X is greater than 3. So 3.1 is applicable. 3.01 is applicable. Even for that matter, 3.001 is also applicable. But 3 is not applicable. Likewise, X is less than 7. So 6.9 is applicable. 6.99999 is also applicable. But 7 is not applicable. Are you getting me? So what exactly we are going to draw? Here it's 3. Here it's 4. Here it's 5. Here 6, here 7. 2 extra elements, sir said. Actually it is 1. I'm keeping on repeating the same thing. 8, 9, let me say 2 and 1. Now we start. Various ways to present. Since 3 is not included, we put a hollow circle on 3. Since 7 is also not included, 3 and 7 are excluded, we put a hollow circle on 7. And we darken the mid path. This says that 3.0001 is applicable, 3 is not applicable, 6.999 is applicable, 7 is not applicable within the solution set. So that's what we say, all the solutions between 3 to 7 excluding 3 and 7. Now this is one way to present via hollow circle, right? There is one more way. Instead of presenting via hollow circle, what is that way? Via arcs. So I need some space, so I'll show you here. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's start. X is greater than 3. So this kind of arc, curvature. X is less than 7. So 6.99 will do, but exactly 7 will not do. You know this curve inside, curve outside. From here it is inside. Here it is outside. Stating us 3.001 will do, but 3 will not do. And then entire stuff. Are you getting me, children? Both are very well accepted. Some of the schools follow this, some of the schools follow this. Board accepts both. Yes or no, children? Right? We'll make some change in our question. The change will be, so I'm going with a different marker. Instead of 3 less than x less than 7, x belongs to R. Our question is 3 less than or equal to x less than or equal to 7, where x belongs to R. So our solution set shall be the same. Only thing is that we are going to write down solution set belongs to, it contains all x such that x belongs to R, and we write down the entire inequality 3 less than x less than or equal to 7. Line graph. So let me draw the line graph of the same. If I take this particular method, circle 1, then once again I'm going to jot down 3, 4, 5, 6, 7, 8, 9. Here we will include 3. 3 is less than or equal to. So x is greater than or equal to 3. X is greater than or equal to 3. X is greater than or equal to 7. So here we will include 3 and 7. Since we include 3 and 7, one more element here also, 2 and 1. Since we include 3 and 7, instead of hollow circle, since inclusion of element is there, we go for a dark circle. Even 7 is also there, we go for a dark circle. And then in between, now I am retracing the path. You did not. Just take a dark pencil, or just do it twice, thrice. Right? It will darken the path. Are you getting me, children? What about this case? The same sum, if I were to present, then it's going to be in this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Since I'm including both, since I'm including both, that is 3 and 7, instead of this curve, we are going to put a straight line. Straight line, which suggests 3 and 7 both are inclusive. Which suggests 3 and 7 both are inclusive. And we go for this. Tells us all the decimal values, all the fractions are included in the solution set. Why? X being a real number. Real numbers has all the decimals and all the fractions. Even this dark portion says that everything is included. Here also this dark portion and this shading portion says that everything is included. We need to be very careful of less than or equal to and less than sign. That's it. That's it. Now if the question arises, sir, what if they say X is greater than or equal to 3 but less than 7? So you know what I'm going to do? I'll take a different marker again to make you understand. I hope you have understood this first one. Now you're modifying the sum. When they say 3 is less than or equal to X, or you can say X is greater than or equal to 3, less than 7, since it is less than 7, 7 is not acceptable. So if 7 is not acceptable, instead of a dark circle, you know what I'm going to do? I'm going to change this into hollow. So on one side dark, other side hollow. Why one side dark? Because 3 is included. So whatever number is included shall be presented by dark. Whatever is excluded shall be presented by hollow. Likewise, here since 7 is excluded, now it is not included, a curvature. Instead of a straight line, a curvature inside. Are you getting me, children? Right? So these are the ways to present a linear inequation graphically for integers, for real numbers. Question arises, what if we have infinite series? What if we have infinite series? I have an answer to that also. So here we have given you X greater than 2. Again we are going to go for permutation combination. We'll change the question accordingly. X is greater than 2. Initially we say X belongs to integer. Let me say this time X belongs to natural number. Instead of integer, let me say natural number. As I stated earlier also, for integers, natural numbers, whole numbers, the solution set will be in listing form. Only in the case of real numbers, it's going to be in set builder form. So X is greater than 2 and X belongs to set of natural number. So what will be the solution set? The solution set will be, since X is greater than 2, will 2 come in this? Answer is no. 3, 4, 5, 6. Sir, how many elements are we supposed to include while writing down the solution set at the same time while drawing the graph? At least 3 to 4. I don't want 7, 8, 9. At least 3 to 4, right? And then comma, dot, 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 dot. This comma is very much essential, suggesting that there is one more element coming. Dot, dot, dot indicates infinite. Natural numbers goes to infinity. Right? Now, how about the line graph? How about the line graph? The line graph says that first go and write down the solution as I stated. So 3, 4, 5, 6, 7. But what is the rule? Write down one extra element. We are taking on a safer side 2 extra element on either side. But on one side there is infinity. So it's only on one side we are supposed to take care of writing 2 extra element, which is 2 and 1. Which is 2 and 1. Okay. Now 3, 4, 5, 6 is what we highlighted. X belongs to natural number. 4, 5, 6 with the darker circle, darker dot. Sir, this 7, even if you have not written, will do. Not needed also. But then, will do. Not needed also. Then this arrow should be darkened. And please put 2 dots, couple of dots here. Please put couple of dots here. This signifies that many numbers are there. It's an infinite series. Many numbers are coming. Right? One care needs to be taken. What happens is that children have this habit. When I say arrow should be dark, they knowingly, unknowingly do darken this portion compared to the previous number line, the previous part of the number line. No children, this is not. When you say you are darkening this portion, suggest all the numbers will come, real numbers will come. We are into natural numbers. So what is needed? What is needed? Darkening of this portion is not needed. What is needed is only darkening of arrow. Darkening of arrow is needed and couple of dots. Couple of dots. What if the same question? What if the same question were to say that here, okay, here I say greater than or equal to 0. X is greater than or equal to 2. So what is the answer then? Solution set. We are going to include this term 2. So 2, 3, 4, 5, 6, dot, 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 dot. Answer will be the same. Only thing is, we'll have 2 over here. Only thing is, we have 2 over here. Now, what is the question going on right now in your mind? There are many questions right now going in your mind. Many going in your mind. Sir, what if I write down 3, 4, 5, 6, 7, 8, comma, dot, dot, dot. And what if I present 3, 4, 5, 6 only? Or vice versa. I write down 3, 4, 5, 6 and present 3, 4, 5, 6, 7, 8. Nothing is going to go wrong. Why? Because it's an infinite series. But I would request you people, care should be taken presentation wise that whatever numbers you show over here should be shown. Nothing less, nothing more. Nothing less, nothing more. Right? So I hope you have understood this. But what if instead of natural number, it belongs to a set of real numbers? So what is the thing going to be? Let's see. So we take same part, some different question. Say this is second part. X is greater than or equal to 2, or first x is greater than 2, then we'll take equal to sign, and x belongs to real number. Earlier it was belonging to natural number. Now it belongs to real number. Now what should be the answer then? Your solution set will not be in listing method. Your solution set will be in set builder form. It comprises of all x such that x belongs to real number, x is greater than 2. And how the line graph is going to be? How the line graph is going to be? 2, 3, 4, 5, 6. Real number. Again, x is greater than 2. So it's going to be an infinite series. Extra element 1. If you want, you can say 0 also. 2 extra elements. Are we going to include 2 here? The answer is no. The answer is no. So 2 is excluded. 2.001 accepted. 2.0001 accepted. But 2 is not accepted. X is greater than 2. So since 2 is not accepted, we are excluding it. So a hollow circle. If I take this method, but it's an infinite series, we shall go and say at the same time, I shall just once again retrace this number line to make it a bit darker, and arrow also dark. Arrow also dark. This suggests other than 2, everything till infinity is acceptable. All the fractions, all the decimals, everything. Right? 2 is not acceptable. Now what is the other method? What is the other method? The other method is, we'll write down the same stuff. 0, 1, 2, 3, 4, 5, 6. If I go by this method, then what shall be the answer? Since 2 is not acceptable, we'll go for a curve and then a line. Even we'll darken this line, we'll darken this arrow, mind you. We'll darken this line at the same time here, and we go for shading. Right? This is how we present for an infinite series. Sir, what if they give, so with a different marker, mind you, x is greater than equal to 2. Again, if we have to include that, we will dark this, and instead of a curve, we'll put a straight line. Otherwise everything remains the same. Everything remains the same thereafter. Are you getting me, children? So see to it that you should know how to present a graph, or how to present our solution set on a line graph when we have integers, when we have real numbers, for finite one, and this is for infinite one. As and when we come across various sums, there will be minor permutation combination, minor changes coming. We will see those also. Now, since I have stated that I'll make you understand for fractional one, what if there is a fraction involved? So let's take one more question. Sum number 3 for fraction. 3 less than x less than or equal to say 17 by 3. 3 less than x less than or equal to 17 by 3. And here we are taking only one answer. We are taking x belongs to real number. Because fractional part, it cannot be integer, it cannot be natural number. It has to be real number. Right? So what is the solution set going to be? The solution set should be, solution set comprises of all x such that x belongs to real number. 3 less than x less than or equal to 17 by 3. Let's go and draw it. 3, 4, 5. First of all, think how much is 17 by 3 going to be? 17 by 3 is going to be ballpark 5.66666, right? So it's going to be between 5 and 6. So 3, 4, 5, 6. How many extra elements we said? 2. I have a reason and I am going to make you understand. So 2 over here, 2 over here. Now x is less than 3. So I'm not going to make you understand both the methods. I'm going to make you understand only one method. X is less than 3. Greater than 3. I'm really sorry. X is greater than 3. You can say 3 is less than x. So since 3 is less than x or x is greater than 3, so 3.01 is applicable. Curve. Now 17 by 3. 17 by 3 is nothing but, if you want, you can place it in fraction also. In your rough column, you can say 17 by 3. Can I write down as 3 5s are 15? So 5 2 by 3. 5 3s are 15. Either you write down in fraction or you write down in mixed fraction. Both are acceptable. Now, how to present 17 by 3 on a number line, a fractional on a number line? Many students do by rough, calculations. Anywhere, when they know that it lies between 5 and 6, after presenting in a mixed fraction, every child gets to know that it lies between 5 and 6. So somewhere down the line, anywhere or in between, they have a habit of writing this as. That's a wrong way, children. That's a wrong way to present 17 by 3 or 5 2 by 3. Not in between. So how and what care needs to be taken? Please pay attention. What care needs to be taken? Now when I know that it lies between 5 and 6, what is the denominator? The denominator of fraction over here is 3. I need to divide 5 and 6 into 3 equal parts. So for that, are we going to take measurements? No. With eye vision, more or less equal, 3 equal parts. 1, 2 and the third equal part. So now tell yourself, this is 5, this is 6. Actually, it is not 5. In integer form, it is 5. If I want to present the same thing with a denominator 3, this is not 5. This is taken as 15 by 3. With the denominator 3, this is not 5. This should be taken as 15 by 3. The next one is going to be 16 by 3. Followed by that is going to be 17 by 3. So just underline it or rather highlight it, pull it down and say 17 by 3. Or for that matter, you could have taken 5 2 by 3 also. Or for that matter, you could have taken 5 2 by 3 also. I repeat, 5, that is 15 by 3. Next is 16 by 3. Immediately the next one, pull it down, 17 by 3 or 5 2 by 3. Are you getting me? Now, when we have this kind of fractional 5 2 by 3, and I said that actual norm is taking extra element, only one extra element, in such cases 6 is not regarded as an extra element. 6 is not regarded as an extra element. The extra element should be 7. The extra element should be 7. One more on a safer side. Now, still we are not done. It is less than or equal to. Since it is less than or equal to, so it's a straight line, and then we hatch it. Are you getting me, children? Sure. So this is how we present in a fractional way. It can work out on either side also. Same thing, right? On left side also, right side also, right?